In section 12-1, we will be covering the subject of tangent lines. The tangent to a circle is defined as a line, segment, or ray in the plane of the circle that intersects the circle at exactly one point. The point of the tangency is the point where the tangent intersects the circle. Theorem 12-1 states that if a line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. Now we can apply Theorem 12-1 to find angle measures. Because MN and ML are tangent to O, according to the theorem, angle L and angle N are right angles. Now let's try solving for the measure of angle N. Because the shape formed is a quadrilateral, we can assume that the sum of the angles is 360 degrees. Therefore, we can say that the measure of angle L plus the measure of angle M plus the measure of angle N plus the measure of angle O is equal to 360. Now we just plug in the values. 90 plus the measure of angle M plus 90 plus 117 should be equal to 360. Now you simplify that to get 297 plus the measure of angle M equals 360. Now just solve for M to get the measure of angle M is equal to 63. To find the length of TE, you can use the Pythagorean theorem. CT squared is equal to TE squared plus CE squared. Now you can plug in to get 20 squared is equal to TE squared plus 10 squared. 20 squared is equal to 400 and 10 squared is 100. Therefore you would get 400 is equal to TE squared plus 100. Now you would solve by subtracting 100 from both sides to get 300 is equal to TE squared. Now you would need to take the square root, so your final answer would be square root of 300 is equal to TE. Theorem 12-2 states that if a line in the plane of a circle is perpendicular to a radius at its endpoint on the circle, then the line is tangent to the circle. To find the radius, we can apply the Pythagorean theorem again. AC squared is equal to AB squared plus BC squared. Now you can plug in to get parentheses x plus 8 squared is equal to 12 squared plus x squared. As you evaluate the equation, you would get x squared plus 16x plus 64 is equal to 144 plus x squared. As you continue to solve, you would get 16x is equal to 80 and x is equal to 5. Theorem 12-3 states if two tangent segments to a circle share a common endpoint outside the circle, then the two segments are congruent. Using Theorem 12-3, we can conclude that AD is equal to AF, and BD is equal to BE, and CF is equal to CE. To solve for P, or perimeter, we can take P is equal to AB plus BC plus CA. We should get a perimeter of 66. In section 12-2, we will be discussing chords and arcs. First, let's discuss what a chord is. A chord of a circle is a segment whose endpoints are on the circle. For example, the endpoints here would be R and D. Theorem 12-5 states that within a circle or in congruent circles, congruent central angles have congruent chords. The converse of this theorem states that within a circle and congruent circles, the congruent chords have congruent central angles. Theorem 12-6 states that within a circle or in congruent circles, congruent chords have congruent arcs. The converse of this theorem states that within a circle or in congruent circles, congruent arcs have congruent chords. Theorem 12-7 states that within a circle or in congruent circles, chords equidistant from the center or centers are congruent. The converse of this theorem states that within a circle or in congruent circles, congruent chords are equidistant from the center or centers. To find the length of chord SR, we can take PQ is equal to QR because that's given to us. Now, PQ plus QR is equal to PR. If we plug our values in, we can take 12.5 plus 12.5 is equal to PR. Therefore, PR is equal to 25. Now, using Theorem 12-7, we can say that RS is equal to PR. Therefore, RS is equal to 25. Theorem 12-8 states that in a circle, if a diameter is perpendicular to a chord, then it bisects the chord and its arc. Theorem 12-9 states that in a circle, if a diameter bisects a chord that is not its diameter, then it is perpendicular to the chord. Theorem 12-10 states that in a circle, the perpendicular bisector of a chord contains the center of the circle. To find the measure of R in this circle, we can take LM is equal to 1/2 of 14. Therefore, LM is equal to 7. We can then use the Pythagorean theorem to say that R squared is equal to 3 squared plus 7 squared. Now to complete the equation, we can take the square root of R squared and the square root of 3 squared plus 7 squared to get R is approximately 7.6.